name is Shivani. I'm a new Wyzant tutor, and I'm here to help with a physics problem involving some heat and some temperature and phase changes. So let's take a look. A 1.5 kilogram ice cube at 0 degrees Celsius has sufficient heat added to it to cause total melting, and the resulting water is heated to 80.8 degrees Celsius. How much heat in kilojoules is added? For water, the specific heat, or C, is 4,190 joules per kilogram per Kelvin, and latent heat of fusion, or LF, is 334 kilojoules per kilogram, and latent heat of vaporization, or LV, is 2,257 kilojoules per kilogram. So in this case, let's take a look at what we have going on. So first is the ice is going to melt at a constant temperature of 0 degrees Celsius. And the next phase is it's going to be heated. So the water, the liquid water now is going to be heated from 0 degrees Celsius to 80.8 degrees Celsius. Now, since the temperature has not hit 100 degrees Celsius in this problem, the water has not reached boiling point or vaporization yet. So we do not need to use this LV value. We're only going to need C and LF. And here's the setup that I have. I have recorded the mass, the latent heat of fusion, the specific heat, which I converted to kilojoules, using the fact that there's 1,000 joules in 1 kilojoule. And I've also recorded the temperature change of the water in that second phase, where the water is heated to 80.8 degrees Celsius. So the temperature change is going to be in Kelvin, since the units of specific heat is in Kelvin. Now it's 80.8 Kelvin. And even though Celsius has to be converted to Kelvin, the temperature change is always going to be the same, whether it's Celsius or Kelvin. And this makes sense because when you're converting between the two temperature units, you're only adding or subtracting. So the temperature change is always going to be the same, whether it's Celsius or Kelvin. Just a thing to keep in mind for future problems. So I have also written down this equation. The total heat added is going to be the heat added to melt ice at a constant temperature of 0.0 degrees Celsius, plus the heat added to raise the temperature of the liquid water from 0 degrees Celsius to 80.8 degrees Celsius. So let's go ahead and calculate those. So the heat added to melt the ice is going to be the mass times LF, the latent heat of fusion. And so that would be 1.5 kilograms times 334 kilojoules per kilogram. Notice how the units cancel out, so you're left with kilojoules for the units in your final answer. And this value here is going to be, let's see, 1.5 times 334. That would be 501 kilojoules. Now let's calculate the heat in that second phase. So that is going to be m times C, the specific heat, times the temperature change. So that's going to be 1.5 kilojoules times, 1.5 kilograms times 4.190 kilojoules per kilogram times Kelvin times 80.8 Kelvin. Now again, notice how the units cancel out here. So we have kg and kg, Kelvin and Kelvin, and we're left with kilojoules in our final answer units. And our answer for this portion would be 1.5 times 4.190 times 80.8. That would be 507.828 kilojoules. And then the total heat added would be the sum of these two. So that would be 501 kJ plus 507.828 kJ, which is, let's see, so that would be 1008.828 kilojoules. And let's see how much we can round this to. So yeah, we can round this to 1009 kJ if you'd like. But yeah, this would be our final answer here. So just gonna write that down here real quick. All right, so that pretty much sums up the answer and the explanations. If you have any questions, feel free to leave a comment in the comment section, and I hope this helps. Have a good rest of the day.